All right, so this is our last day of school, our last review. Let me get the answer things right up here. Got the test there. All right. Did we go over the? We didn't really go over, did we? The last test, the chapter 12 test. I don't think we really went over it. Okay, so we'll do it today. But most of you did pretty well on it. But if you have questions, we'll do it. All right, so this is going to be, we're just kind of a scanning review, right? It's not going to be like in depth. I'm not going to do every single problem here. But if there's a couple that you're not sure about, maybe we will do those. But let's just see what we got. Just remember, so this is only one chapter ago, even though we went from 8 to 12, all right? We skipped those other ones in between. So here we go. Let's do this. What do we know about some of this stuff? Let's blow this up a little bit. Even if you're not taking the test, you can participate, can't you? So what do we know about this? This is AH is a what? Oh, that's Aaron Hamrick. That's me. So AH is what? It's a radius, and AD is a radius. All right. What is this? What's IF? Give me one word. It's a chord. And what's true in this particular situation? It doesn't always happen, but what's true in this particular situation? That chord and that radius are what? They're perpendicular to each other. So what does that do? What does it do to that chord? It bisects the chord. That's right. So basically, that's what you need to know about this problem right here. Everybody got that? So it says find AI. Oh, I know. I was going to say, it seems like I just did this the other day. It was from my other class. My one of my CP classes. We just went over this. So it says find AI, and AI is not drawn, so what do? You draw AI, right? And then AC and AG are equal to each other, all right? So they do tell you that. Now, we wouldn't know that without them telling us. So that one and that one are equal to each other. BE is 10. I said I wasn't going to do all these. So if BE is 10, what's this? Oh, sorry. BE, the whole thing is 10, so what's this? That's 5, and that's 5. Look, if these two are equal to each other, what do you think is true about, well, both the radii are equal to each other as well. So what's true about the chords then? Then they're going to be equal to each other as well. Okay, we have a thing. I forget exactly what the theorem was and what it said exactly, but that's basically what's happening here, all right? So, yes, if that little thing right here and that little thing right here are equal. So if that's 5, what's this one right here? That's 5. AC is 4, so they tell you that this little bit is 4, which means what? AG is also 4 because they're equal to each other. All right. Now, is this a 3, 4, 5 triangle? Because you got a 4 and a 5, and it's a right triangle, but it's not. Why not? Because the hypotenuse is not 5, right? So what are you going to have to do? Use the what? Pythagorean theorem. That's right. So you could do that yourself. It comes out to the square root of 41. Okay? That's AI right there. So if you do Pythagorean theorem, that's really all there is to that problem. All right, enough of that. I said I wasn't going to get it in depth, but I did on that one, didn't I? Same kind of thing, right? It's basically the same theorems, the same stuff that we know about a radius and a chord being perpendicular. Do you see that? You got the same situation here, except we don't just have regular numbers. We have letters. We have variables in there as well. So that's what we do. Well, let's just kind of set this up. So find AC. So we'll just call that little x right there, okay? So find AC. Actually, let's not call it x because they give it to you. This is 2x plus 6, 2x plus 6, that little bit right there. JG, oops, what did I just do? Let's try this. That's better. Oops, get rid of that, get rid of it. What's that line right there? There it goes. That was weird. I don't know what I did. What did I say this was? 2x plus 6? There we go. And it says JG. So if JG is 4x minus 10, what do I know? Yeah, 4x minus 10. What do I know about these two things? AC and JG. They are equal to each other, okay? If they're congruent circles and all that kind of stuff. And if BE equals FI, do you see that? BE, that chord, equals this chord right there. Then this little part right here and this little part right here are exactly the same. So you just set them equal, solve for x, plug it in, and you're good to go. All right, I'm not going to write down every answer because I gave you the test, right? And if you got it wrong, I put the answer next to it. If you got it right, you know what the answer is, all right? So I don't need to write them down. There you go. Same kind of idea with number 3. There we go. Let's move to this one. All right, what do we know about this? So if we have a point outside a circle, what is EF? Give me the name of EF. What do I call that kind of line? It's a tangent, right? Because it hits, and what's that point F right there? It's the what? Point of tangency. So it hits at the radius, right? The radius hits the point of tangency. What must be true about the tangent and the radius? They are perpendicular, correct? All right, so right here and right here, those are perpendicular. And the same with this, all right? There's your right angle right there. There's your right angle right there. So this one just says find angle C. So what do I do? If that's a right angle, that's a right angle. What do I do with this one and this one? Set them equal to what? Yeah, add them up, okay, and then set them equal to 180. Why not 360? That's right, because these two add up to 180. So technically we are taking 180 away from 360, aren't we? Yep. So it's just easier going 3x plus x, it's 4x, equals 180, solve for x, and then that's angle A, but they ask for angle C, don't they? So once you find x, you multiply by 3 to get that angle, you're good to go. Everybody with me? Coming back to you? Wasn't that long ago, was it? Seemed like it was just the other day we did this stuff. I don't know. Maybe. EF. This one right here, GH, they tell you GH. Well, GH and FG are the same thing, aren't they? So that would also be 25 right there. EG, where's EG? That's this one right here. That would be 65. And you want to find EF. We'll just call it X. All right. So what would you use for this? Used it once already today. Pythagorean theorem. You got a right triangle, use Pythagorean theorem. So it's 25 squared. Is it plus 65 squared? No. It's what? Plus x squared. So this would be what? X squared plus 25 squared equals 65 squared. And then you solve for x. And yeah. And then you can, and that's what EF is. All right. So whatever you get for that, there you go. 65 squared calculator, right? That's a big number. I don't know what that is off the top of my head. But then you subtract 25 squared from it, take the square root, boom, you got x. No biggie. Everybody good? All right. Oh, that actually comes out nice and even. Oh, yeah. I could have done this. I didn't think about this. But look, what divides evenly into 25 and 65? 5 does. So that goes 5 times. This goes what? 13 times. So you could have said, right, 5 what? 5, 12, 13. But it's not 12. It's what? 12 times 5, which is 60. That would be even easier, wouldn't it? Knowing your Pythagorean triples. Did I? Okay, I can't remember if I did or not. I didn't think about it at first. I automatically went right to Pythagorean theorem, but then I noticed that 5 goes into both of those. So yeah, that works out nice. If you were to take, like next year, do you take it as a sophomore, the PSATs? I think you do. All right, so look for that kind of stuff next year when you take the PSAT, because there's going to be a lot of geometry on there, and look for the shortest way to do things, all right? And Pythagorean triples really, really help out. I could almost, I haven't seen those tests in years, but it used to be, they'd always have something like a 3, 4, 5 triangle on there, right? Where a lot of times you can just look at it and bam, really quick get the answer. While other people are writing out the whole Pythagorean theorem, they're doing all the algebra and all that, and you just look at it, oh yeah, 3, 4, 5, boom, it's 5, it's 4, it's whatever, okay? All right, enough of that. Let's do this. You know about the arcs and the central angle, right? So if this is 50 degrees right there, what's arc BC? That's 50 degrees, all right? I'm not going to do the whole problem. We're just going to talk about it, all right? If that's 45, that's 45. And then, look, there's a straight line, isn't it? That's a diameter, that whole thing right there. All right, so you could figure out what that is. How would you do that? That's what? That's 95. So what would that be? 105, is that right? 105 and 90? No. How am I not doing this in my head? It's 85, 180, 180 minus 95, 85. Why am I not seeing that? 180 minus 95. That's a 17, and that is an 8 and a 5, right? Okay, so that'd be 85, that would be 85, and so on, all right? So once you get this one, if that's 30 degrees, you know that's 30. If that's 20, you know that's 20. We said that's 85. How would I find this big one right here? Yeah, you could go 180 minus 50. Good, 130, right? So what should all those add up to be? 360, right? So you can do all that. And you know the arcs are the same. Yeah, piece of cake. 6, 7, and 8, no big deal. Those are kind of easy, aren't they? With central angles. All right, what about this one? The length of. Do you remember this? The length of an, let's do this real thick. The length of an arc right there. Right? How do I find the length of that arc? Well, what's the length, what's the distance around a whole entire circle? It's the what? Give me a word. Give me a good geometry word. It's the circumference, right? It's the circumference of the circle. What is circumference equal to? 2 pi r, correct? Why is the writing so thick? Let's make it a little thinner. All right, so it's 2 pi r. But we're not finding the circumference of the whole circle. We're only finding a circumference of how much of the circle? How much out of 360? 75 out of 360. Okay? That's, well, I'll tell you what. Let's not put 75 just yet. Let's be more general. So what did we use to be general for that angle? What letter did we use for, what is it? Theta, right? We use theta. All right, so there's our general formula for the length of an arc. Everybody got that? You got to know it. Write it down. You got to know it. So this one's straightforward. This is just finding the length of arc XY. So you just plug everything in. No biggie. All right? What about this one, though? It's kind of the same thing, but you got to solve for something, though. You got to do some algebra on this one. This one's straightforward. All you do is just plug the numbers in, right? Plug a 75 in for the theta, plug an 8 in for the radius, and then you just throw all that into a calculator. Boom, you got an answer. Okay? No algebra really involved, but there is definitely algebra involved here. So you could put numbers in. Yeah, let's put the numbers in. So the length. What is the length of this arc from here to here? Yeah, 3 pi over 2. Most people look at the 3 pi and are like, oh no, 3 pi over 2, it's a fraction, you got pi in it. It makes it really hard. Actually, the pi makes it a little bit easier, to tell you the truth, because what's going to eventually happen with the pi's? They're going to cancel out, all right? So it does make it a little easier. So what is it? Pi equals, I'm not going to do the whole math, but we will do the algebra. Okay, so it's 45 over 360 times 2. I'm going to put this all on top. Times 2 times pi times what? R. And R is what we're solving for. Okay? So let's do the algebra. If I want to get R by itself, here's first thing I would do. I see a pi on one side, pi on the other side. What can I do with both of those? Yeah, cancel them. Now, not multiply. If I multiply this by pi, I'd get pi squared. So I don't want to multiply it by pi. I want to divide it. Technically, I'm dividing by pi, correct? But what happens whenever I divide both sides by pi? They cancel out. So I can just look at it like that. If you wanted to, you could take the 2 into the 360, all right? 2 into 360 is what? 180. You could simplify that if you wanted to, but eventually, what are you going to do? How are you going to get rid of that fraction right here? You're going to multiply it by its reciprocal. So I'm going to put 180 here, and I'm going to put 45 down the bottom. Everybody see that? I'm dividing by 45. It cancels. I'm multiplying by 180, right? Multiply this side by 180. That cancels. Do it over here. And then just clean it up, right? You can do it in your head, maybe, or just stick it in a calculator. We good? All right. Same thing with this. Same exact thing. I'm not going to go through the whole process again, but this time we're going to solve for theta. All right, so if I wanted to solve for theta, how do I get rid of the 360? Multiply it by 360. How do I get rid of 2 pi r? Divide it by 2 pi r. So technically, if I wanted to write it without putting my numbers in, here's what theta would equal. See, can we do that in our head? So we're going to we're going to multiply by 360. So what do I get? I got a 360 what? L. And then I'm going to divide by 2 pi r. So what am I going to get here? 2 pi r. That's kind of nice, isn't it? Without all the numbers. And now I can just plug everything into this. Yeah? That's something, I taught physics for a lot of years at my other school. I haven't taught it here before, but this is what we did. Sometimes you get these really long formulas. You'll probably have this in chemistry next year. You'll take chemistry, right? You take biology this year, right? Yeah, so next year you'll take chemistry. You're going to use a lot of this algebra that we've been doing this year in chemistry class as well. All right, and that's really, really helpful. Solve for what you want to solve for before you start throwing the numbers in. All right, I think it's a lot easier. But some students, especially when they're younger, they get a little confused on this. But the better you get at your algebra skills, the easier it is to recognize that. Okay, enough of that. Let's do this. All right, let's talk about this. This is not a central angle now, is it? What do we call this thing? An inscribed angle. So that angle is half the arc that it cuts off. Remember that? So this comes all the way out. I'll tell you what, let's just write it. This comes out and hits at D. All right, and this comes out and hits at H. Everybody see that? So look at the arc that it cuts off. It cuts off. I'm not going to do this for everything. I think I did a review on this where I did the whole entire problem back when we reviewed for this test originally, I think. So if that's 49, what's that whole fat arc right there going to be? It's not 49. It's not a central angle. Times 2, right. The arc is twice the inscribed angle, or the inscribed angle is half of the arc. Okay, this time we're trying to find the arc, so that's double this. What's double 49? How about 98? Okay, if I double that, right? You get the idea? Do you see any other inscribed angles? Yeah, from there to there, right? Everybody see that one? Right, to there. So if that's 31, what's this arc? That's 62. You see any more inscribed angles? Wasn't there another one? What is it? BG, EG, EG. Well, you could find that. You could find arc EG by adding those two together. That's all the inscribed angles, isn't it? Yeah. Yep. And you can find some other stuff, right? Like you could find HG if you wanted to, because now you know all the arcs except for this, right? So look, you know 98, you know 94, you know 62, you know 48. This is the only one that you don't know. So how would I find that? I would add up all those arcs and take it away from 360, right? Because it's a circle. It's not 180. It's 360. So whatever that is, I don't know what that is off the top of my head, but that's how you could find that. All right? So if this is 62, let's see. What is it from E all the way to G? Because here's another inscribed angle. Because we said, was there another one? And there it is right there. It was right in front of my face. I don't know why I didn't see it. So what is this? This is, what, 110, right? So from here to here is 110. So what's this angle right here? That's, right, 55. So then I should be able to find this angle right here, correct? Add them up, take them away from 180. If I can find that angle, I can find this angle because they're exactly the same. They're vertical angles. Then I can find this angle right here, right? Because you add those up, take them away from 180. And if you wanted to, you could find that angle. You could find this angle. You could find this angle. Man, you could find everything now, given that information. Everybody good? All right. So I'm not going to go through each individual one of those. All right, let's do this one. These are secants, right? Because they go through the circle. So what do we know about the secants? They intersect inside the circle. So what is the rule? What is the little theorem, the formula that we learn when two secants intersect inside the circle? We can find this angle right here by doing what? Add the two arcs. All right, so 74 plus 82, and then what do? Divided by 2. And that's equal to angle X. So this angle right here, that's what it's equal to. You can do the math on that. Everybody good? What happens when they intersect outside of the circle? Remember, this is inside the circle. You add them. What happens when they intersect outside the circle? You subtract. Now, again, we're finding either this angle or that angle. It doesn't matter, does it? Right? Because they're the same. All right, so what's y equal to? So angle y is equal to, you subtract the two arcs. What are my two arcs now? It's the 250 minus the what? The 64. Doesn't matter what order you subtract them in. Yes or no? Did I stump you? Thought that would be easy. Doesn't matter what order you subtract. It always matters what order you subtract, okay? So you always take the bigger one minus the smaller one, okay? And the bigger one's always going to be further away, all right? So this one, it's always going to go the one that's further away minus the one that's closer to that angle. It's always the biggest minus the smallest. Everybody got it? What about if you add them? Did it matter if I went 74 plus 82 or 82 plus 74? No, because addition, it doesn't matter. Subtraction, it does. And then what do we do with this? We divide it by 2. Everybody good? All right, what about this one? Angle Z. So angle Z. They're two secants. By the way, this was a tangent and a secant. All right, this are two what? Yeah, I said secant, didn't I? I misspoke. What are they? They're two tangents, okay? And they intersect outside the circle, correct? Any tangents are, because tangents don't go inside the circle at all anyway, right? See, these are always going to intersect outside the circle. So, same thing with this. So, what do? We subtract and then divide by 2. Well, they only give you the one arc. They only give you, from there to there, the 122. They don't give you this. How do you find it? That's right. Take 360 minus 112. Let's just do that. 360 minus 112. And that's what? That's a 2. That's a 4. That's an 8. Did I do the math right? So it's 248. What? Minus 112 divided by 2. So you had to find that arc. They didn't give it to you. They gave you all the arcs you needed over here. They didn't give it to you here. So there you go. We good? Oh, we got 2 more of these. All right, here's 2 what? Secants, right? They're 2 secants and they intersect outside the circle. Thought we already had 2 secants. Yeah, no, we had 2 secants inside the circle. This is 2 secants what? Outside the circle. So if it's outside, what do we always do with those 2 numbers, the 2 arcs? We subtract, okay? So let's do that. So this is a little different though. So I'm not going to go A equals. What am I going to go? 36 equals. Okay, the 2 arcs subtracted divided by 2. What are my 2 arcs? This is my bigger one. The one towards the outside is always going to be the bigger one. So I'm going to go what? 86 minus A. So that's how I'm going to set it up. Everybody got that? All right, and now you just have to do some algebra. What would you do first? What would your first step be? Multiply by 2. So multiply that by 2. Now, this is 86 minus A, correct? So you could subtract an 86, but you get a negative, but then you just divide both sides by negative, and you'll get your positive, and that's whatever it is. The answer is 14 on that one. All right, enough of that. Here's 2 tangents. I'm sorry, I keep getting those words mixed up. 2 secants that intersect inside the circle. We did have one of those before, didn't we? But this was super straightforward. They gave that to you as numbers. They asked for the angle in the middle. So there was no manipulation. There was no algebra to do. On this one, yeah, there is a little bit of algebra to do. So the angle in the middle, all right, is what? 61 equals the 2 arcs. What do I do with those 2 arcs? I add them together. That's right, because remember, where is it intersecting? Inside the circle. So when it intersects inside the circle, we add them up. So it doesn't matter what order. I'm just going to go B plus 85. And then we divide that by 2. So now, very easy. Multiply both sides by 2. Subtract 85. And then B is 37 degrees. Okay? All right. Let's do these. I'm going to set these up. I'm not going to do the calculator work. Okay, you make sure you know how to do the calculator work. So what do we do? To find x and y, can I find x and y by Pythagorean theorem? No, because I only know one side. I need two sides in order to use Pythagorean theorem. But let's do x. I do know this angle. What is side x? It's adjacent. And what other side do I know? Okay, hypotenuse. So which one is adjacent and hypotenuse? It's the cosine. All right, so let's set it up. We would take the cosine of what? The angle, 17, equals the adjacent, which is x, over the hypotenuse, which is 20. Right? Multiply both sides by 20, so x equals 20 times the cosine of 17 degrees. So throw it in your calculator, boom, there's your answer. If you wanted to, I guess you could use Pythagorean theorem to solve for y. I would just use a trig function. I think it's probably easier, don't you? Just using the trig function anyway. Plus, it's going to give you a more accurate answer. Because unless you put this exact thing right here in the Pythagorean theorem, you're going to get your approximation is going to be off a little bit. All right. So let's solve for y. So let's solve for this. What is this now? We'll keep the 17. We could have used this angle E up here, couldn't we? All right. I mean, they asked for it. That was the easiest of the problems, wasn't it? Angle E, which is 90 minus 17. All right. But let's not. Let's use this angle right here. So what is this? This is opposite hypotenuse. Trig function is the sine. So let's do that right here. So it's the sine of the angle, 17, equals opposite over. So it's the exact same algebra. We'll just put the 20 right there, right? And then throw in a calculator. Boom, there's your answer. E, 90 minus 17. You're done. We good? All right. Let's do this. Angle B is easy. How do I find angle B? 90 minus 47. Boom, done. But that'll be my answer there. But number 5, B, let's do that. So I'm going to use this angle. And what side do I only know one side? It's very similar to this. Okay, but I know this side right here. So this is opposite and this is adjacent. So I'm going to use the tangent. So oops, I should have put it here. It doesn't matter. This is for number 5. So the tangent of what? 47 equals opposite. I'm just going to do one of these. Then we just need to move on. So the algebra is just a little bit different. The algebra on these first ones, real basic, real simple. It was super easy. Just multiply by the denominator and you got your variable by itself. On this one, it's a little trickier, but you should still be able to do it. At this point, you should still be able to do it in your head. So I want to get the b over here. So what am I going to do? Multiply both sides by b. And then I got to get rid of the tangent of 47. How do I get rid of that? Divide by the tangent of 47. So I'm going to be left with 9 divided by the tangent of 47. Okay? Plug it in your calculator, you're good to go. Do the same thing with the rest of them. No biggie. We good? Yeah. This stuff's really not much different, is it? It's a right triangle. So that's, well, they were all right triangles. We're going to get some non-right triangles in a second. So solve the right triangle. A is 33. So that's 33. B is 17. So look, let's do C first. How would I find C? Pythagorean theorem, no biggie. All right, how would I find A? So this is a little different. Let's do the algebra on this one, okay? So I gave you a good variety of these. I started off super easy, then I made it a little bit more difficult. And this one, probably on right triangle trig stuff, this is probably the hardest one, but really it's not that bad. So let's see what I got. I don't know C, so I don't know the hypotenuse. So I do know the opposite and the adjacent. So we are going to use the tangent. The tangent of what, though? Of K? A. Oh, I think you said K. I was like, I don't even see a K. Good. The tangent of A equals opposite, 33, over adjacent, 17. Now, here's the weird part. What do? I got to get A by itself, so I have to get rid of tangent. How do I get tangent? Or how do I get A by itself? Take the inverse of the tangent. So watch. I can just write it out. Inverse tangent of what? 33 over 17. And put all of that into your calculator. Don't go 33 divided by 17, round it, and then do the inverse tangent. Don't do that. Everybody hear me? Because you'll get different answers. Go put this whole thing, second function tangent, on your calculator. All right, enough of that. Area. How do I find the area of a regular, well, on a regular octagon?
I thought
What is it? Yep. 1/2 the apothem times the perimeter. P is the perimeter of the thing. I can find perimeter super easy. It's an octagon. How many sides is that? 8, and each side is 6. So what's the perimeter of this whole thing? It's 48. Okay, so all I got to really do, the real hard stuff, is to find the apothem. How do I do that? Well, I'm going to come over here and give myself some space. You could draw a regular octagon, but you don't need the whole entire octagon. Do you remember that? I'm just going to do this. And then it doesn't have to be to scale, all right? Whether this was a pentagon, an octagon, a hexagon, whatever gon, all right, I'm going to just do it just like this. The center is probably somewhere around here. Then what am I going to do with that center? I'm going to make myself an apothem. Where is the apothem? It's from the center, perpendicular to any of the sides. Just to make it easy, I'm going to put it right down here. Everybody got that? So that's how I set this thing up. And then I'm going to make a right triangle out of it. So I'm going to go from here to here. All right? And what do I know? I know the sides are 6. So what is it from here to here if I drop this perpendicular? That's going to be 3. And did they tell you anything else? No? Oh, what do I need to know, though? I need to know this, right? That's the apothem. That's what I'm trying to solve for. But I only got one side. How am I going to do that? Well, I got to know some angles. So what am I going to have to do? I'm going to find, this is probably the most difficult problem out of the whole entire test, right? Or the most work involved, I should say. This right here, I should be able to find. How do I find that? That big angle from there to there. Remember, it's a regular octagon. So it's 360 what? Divided by 8. Agreed? And whatever that is. Anybody got a calculator on them? What's 360? I don't have the work in front of me. What is it? Well, 360, 45? Is it 45? Yeah. Okay, so what's this? 22.5, correct? And then I could just use that, couldn't I? And use a little trig. Didn't we have another? No, I guess that's the only way. Is that the only way I taught you how to do it? I think so. So let's just use it then. So let's find A. Let's use that angle. I could find this angle down here, but we don't really need to. I already got an angle right here. It's 22.5. So what is this side to that 22.5? That's opposite. And what's this side? Adjacent. Trig function, tangent. So it's the tangent of what? 22.5 equals the opposite over the adjacent. Get A by itself. So A is what? 3 over the tangent of 22.5. A lot of steps, isn't it? Okay, like I said, this is the hardest problem out of the whole thing. So it's 3 divided by the tangent of 22.5. That's what A is. But in order to find the area that we're trying to find, what do? Take whatever this number is, plug it in right there. A lot of calculator work, right? Plug it in there, times 48, take half of it, there's your area. And that comes out to, what? Oh, I'm looking at the wrong test. No wonder. I was like, I don't see anything like that. 170, yeah, 172.8 is what I got. But if you put 173, I'd give it to you. 172.8. And it's in inches, so it's what? Inches squared area equals. I should put a little squiggly equals because that's an approximation. All right, I got a minute left. Can you believe it? 1 minute. Let's just write down the formulas. I'm not gonna go through it. Let's do law of sines, law of cosines. Remember the law of cosines. What is it? C squared equals A squared plus B squared, and then minus 2AB cosine of angle C. All right? So know how to use it. Okay, go back, watch the video if you forget how to use it. What's the law of sines? Let's start with A first. Yeah, A over sine of A. And then the rest, yeah, it's just the same. You just put the B's and the C's in there. So that's easy to remember, isn't it? Just got to know how to use it. Now, if you were solving for the angle, would you want to write it A over sine of A? Now, I would write, if I was solving for the angle, I would write sine of A over A equals what? Sine of B over B equals sine of C over C. That's what I would do. Okay? And you all remember my YouTube channel, right? I don't think that's on the test. Like law of sines, law of cosines? Yep, absolutely. I will. I'll put a bunch of them on there. Well, everybody get that wrong. Well, you don't know it. Black? Black like my heart? Is that what you're getting at?
Is it purple?
All right. Well, that's it. That's the last time I'm going to teach you guys. Isn't that exciting? Finally, yes. Now, you dump stuff. Hunter, come over here. You dump stuff in my trash can by not paying attention, saying you hate this class.
I just dislike math.
What? You dislike math? There's no way. How can you dislike math?
That sucks.
No, it doesn't.
Just because I can do it doesn't mean I like it.
You'll learn to like it. I promise you. You talk to me when you graduate, and you tell me what your favorite class was, and I bet you anything it's going to be your math class.
I'm gonna miss